If you've taken a DNA test and discovered Assyrian ancestry, you might be surprised to learn that your genetic heritage tells a story far more complex than the simple Middle Eastern label most companies assign to your results. What if the conventional understanding of Assyrian genetic origins was not just incomplete, but fundamentally wrong? In 2017, a comprehensive study of northern Iraqi populations sent shockwaves through the genetic genealogy community, revealing patterns that challenge decades of assumptions about who the Assyrians really are, raising fundamental questions about how ancient populations maintained their biological identity across millennia of conquest, displacement, and cultural change. The mystery of Assyrian genetic origins begins with the extraordinary continuity observed in their DNA across more than 4,000 years. Modern genetic studies reveal that contemporary Assyrians are direct descendants of ancient Mesopotamians. Archaeological evidence from northern Mesopotamia shows continuous human habitation around the ancient city of Ashur for over 6,000 years. The genetic signature of these early inhabitants, characterized by ties to the ancient farmers of the Fertile Crescent, who first developed agriculture, has persisted with remarkable stability. Most ancient populations that built large empires experienced significant genetic transformation through conquest, migration, and intermarriage with subject peoples. The paternal genetic heritage of Assyrians reveals another layer of mystery through their Y chromosome distribution patterns. Modern Assyrian populations show a complex mixture of Y chromosome haplogroups that reflect both ancient Mesopotamian roots and more recent population interactions. The most prevalent haplogroups include J2 and J1, which are strongly associated with early farming populations and ancient city-states in the Fertile Crescent region. These lineages likely represent the genetic legacy of the original Mesopotamian populations, who developed urban civilization and agricultural surpluses that enabled the rise of complex societies. However, the presence of other Y chromosome lineages, including R1b, R1a, and T, adds complexity to the genetic picture. Haplogroup R1b, in particular, has been measured at significant frequencies among Iranian Assyrians, reaching up to 40% in some studies. This high frequency is intriguing because R1b is typically associated with populations from the Caucasus and later Bronze Age migrations. The presence of this haplogroup among Assyrians could reflect ancient interactions with northern populations, possibly related to the Hurrian substrate that influenced early Assyrian culture. Or it might represent later admixture events during the periods of Achaemenid, Parthian, or Sassanid rule over Mesopotamia. The distribution of haplogroup T among Assyrians presents another puzzle. This lineage, found at frequencies of around 15% among some Assyrian populations, is also common among Middle Eastern Jews, Georgians, and Druze populations. The shared presence of this haplogroup suggests ancient population connections that predate the historical period, possibly reflecting the movement of peoples during the Bronze Age or earlier Neolithic expansions. The challenge lies in determining whether these shared lineages represent ancient common ancestry or more recent admixture events. What makes the Assyrian Y chromosome pattern particularly mysterious is the variation between different Assyrian populations. Iraqi Assyrians show different haplogroup frequencies compared to Iranian Assyrians, with JM304 reaching 55% among Iraqi populations, but only 11% among Iranian Assyrians. This geographic variation suggests that Assyrian populations have experienced different demographic histories, despite sharing common cultural and linguistic traditions. The reasons for these differences remain unclear and add to the complexity of understanding Assyrian genetic origins. The mitochondrial DNA patterns of Assyrians reveal an equally complex and mysterious genetic landscape. Assyrian populations display a diverse array of mtDNA haplogroups, including H, HV, K, T, and U, reflecting a history of female migration and intermarriage that spans thousands of years. This maternal diversity tells a story of how women from different regions and cultures became integrated into Assyrian communities through various mechanisms, including marriage alliances, conquest, trade relationships, and voluntary migration. Particularly intriguing is the presence of specific HV subclades among Assyrians that provide insights into ancient population movements and genetic continuity. The HV4A2 subclade, found exclusively among Assyrians and Armenians, has been dated to approximately 8,200 to 12,500 years ago, with an exclusively Assyrian branch dating to 3,300 to 4,200 years ago. This deep temporal structure suggests that some Assyrian maternal lineages have ancient roots in the region, predating the historical period by millennia. The exclusive presence of certain mtDNA branches among Assyrians raises questions about population isolation and genetic drift. Unlike the Y chromosome data, which shows evidence of gene flow from various directions, some maternal lineages appear to have been preserved within Assyrian communities over extended periods. This pattern could reflect cultural practices that maintain distinct maternal lineages, possibly related to marriage customs, religious traditions, or social organization that favored endogamy within specific lineage groups. Recent studies have doubled the number of full mtDNA sequences representing HV4A2 by analyzing Assyrian mitogenomes from diaspora communities in the United States. These studies reveal that many contemporary Assyrians can trace their maternal lineages back to specific ancestral villages and towns in the Assyrian homeland, maintaining detailed genealogical knowledge that extends back several generations. One of the most perplexing aspects of Assyrian genetic history is the relationship between linguistic change and genetic continuity. The Assyrians originally spoke Akkadian, an East Semitic language that served as the diplomatic lingua franca of the ancient Near East. However, during the first millennium BC, Aramaic gradually replaced Akkadian as the spoken language of Mesopotamian populations, including the Assyrians. This linguistic shift was so complete that by the early centuries of the Common Era, Akkadian had become extinct as a spoken language. Typically, such dramatic linguistic changes are associated with significant population movements and genetic admixture. When a population adopts a new language, it often reflects conquest, migration, or cultural assimilation that involves genetic mixing with the new language speakers. However, genetic studies of Assyrians show that this linguistic transformation occurred without substantial genetic replacement. The core Mesopotamian genetic signature remained intact despite the adoption of Aramaic, suggesting that the language change was primarily a cultural phenomenon, rather than the result of population replacement. This pattern is particularly mysterious because it contradicts the typical relationship between language and genetics in ancient populations. The adoption of Aramaic by Mesopotamian populations appears to have been driven by practical considerations related to administration, trade, and communication across the multi-ethnic Neo-Assyrian Empire, rather than by demographic replacement. Aramaic served as an imperial lingua franca that facilitated communication across diverse populations, and its adoption may have been a pragmatic response to administrative needs, rather than the result of Aramaic-speaking populations replacing existing inhabitants. The survival of Akkadian-influenced Aramaic dialects among modern Assyrians adds another layer to this mystery. Contemporary Assyrian languages, known as Northeastern Neo-Aramaic dialects, including Suret and Turoyo, preserve linguistic features that can be traced back to ancient Akkadian. The expansion of the Neo-Assyrian Empire presents one of the most compelling genetic mysteries in ancient history. At its height in the 8th and 7th centuries BC, the Assyrian Empire stretched from Egypt to Iran, incorporating diverse populations and cultures under Assyrian rule. The imperial policy of deportations and population transfers, well documented in historical records, moved hundreds of thousands of people across vast distances, creating opportunities for extensive genetic mixing. Historical sources describe how Assyrian kings systematically relocated conquered populations to prevent rebellions and integrate diverse groups into the imperial system. These mass deportations brought people from Anatolia, the Levant, Iran, and other regions into the Assyrian heartland, while Assyrians were settled in conquered territories as administrators, soldiers, and colonists. Such extensive population movements typically result in significant genetic admixture and the creation of hybrid populations with mixed ancestry. However, genetic studies reveal only minimal traces of this expected admixture. While there is evidence of small amounts of gene flow from Anatolia, Iran, and the Levant during the imperial period, the dominant genetic signature remains Mesopotamian. The reasons for this limited genetic impact remain unclear and represent a significant puzzle in understanding ancient population dynamics. One possible explanation is that Assyrian imperial policies maintained ethnic hierarchies that limited intermarriage between Assyrian administrators and local populations. Elite Assyrian families may have practiced endogamy to preserve their status and identity, resulting in limited genetic mixing despite extensive cultural and political interactions. Alternatively, the demographic impact of deportations may have been smaller than historical records suggest, with most population movements involving relatively small numbers of people compared to existing populations. The conversion of Assyrians to Christianity in the 1st through 3rd centuries AD introduced new cultural dynamics that may have influenced their genetic patterns. Unlike many other populations in the Middle East, Assyrians maintained their Christian faith through successive waves of conquest by Persians, Arabs, Mongols, and Turks. This religious continuity created social boundaries that may have contributed to genetic isolation and the preservation of ancient genetic lineages. Christian Assyrian communities developed distinct ecclesiastical and cultural traditions that emphasized their unique identity and heritage. The use of Syriac as a liturgical language, combined with traditions that connected them to ancient Mesopotamian civilizations, created a cultural framework that encouraged endogamy and community cohesion. Marriage practices within Christian communities may have limited gene flow from surrounding Muslim populations, contributing to the preservation of ancient genetic signatures. The development of different Christian denominations among Assyrians, including the Church of the East, Syriac Orthodox, and Chaldean Catholic churches, created additional social structures that influenced marriage patterns and genetic exchange. Each denomination developed its own traditions, territories, and social networks that may have created micropopulations with slightly different genetic characteristics. This religious fragmentation could explain some of the genetic variation observed between different Assyrian communities. Archaeological and historical evidence suggests that Assyrian Christian communities maintained strong connections to their ancient heritage through religious festivals, cultural practices, and oral traditions. The celebration of traditions like Akitu and the preservation of ancient customs within Christian frameworks demonstrate cultural continuity that parallels genetic continuity. Assyrians traditionally inhabited mountainous and semi-mountainous regions of northern Mesopotamia, southeastern Anatolia, and northwestern Iran. These geographic settings may have contributed to their genetic isolation and the preservation of ancient lineages. Mountainous terrain typically creates natural barriers to population movement and can lead to genetic isolation of highland populations. However, the degree of geographic isolation experienced by Assyrians is debated among researchers. While some communities were indeed isolated in remote mountainous areas, others lived in major cities and trade centers where they would have had extensive contact with diverse populations. The Assyrian communities of Urmia, in Iran, for example, were located in an important agricultural and trade region that connected Iran, Anatolia, and Mesopotamia. Population bottlenecks during periods of persecution and displacement may have also influenced Assyrian genetic patterns. The deportations during the late Ottoman period, including the events of 1915, resulted in dramatic population losses. Estimates suggest that upwards of 250,000 Assyrians were killed during World War I, with entire communities being destroyed or displaced. Such severe demographic contractions can lead to genetic bottlenecks that reduce genetic diversity and amplify the frequencies of certain lineages. The survival of Assyrian populations through these demographic disasters represents a remarkable case of population resilience. The fact that modern Assyrian communities retain genetic signatures that can be traced back thousands of years, despite experiencing repeated population bottlenecks, suggests that either the bottlenecks were less severe than historical records indicate. Understanding Assyrian genetic origins requires comparison with neighboring Middle Eastern populations to identify shared ancestry and unique characteristics. Genetic studies consistently show that Assyrians cluster separately from their geographic neighbors, including Arabs, Kurds, Turks, and Persians. Comparative studies reveal that Assyrians are most closely related to other populations with ancient Mesopotamian heritage, including Iraqi Arabs, Mandeans, and to some extent Marsh Arabs. These shared genetic affinities suggest common ancestry in ancient Mesopotamian populations, but the degree of genetic similarity varies. The relationship between Assyrians and Armenian populations presents another genetic puzzle. Both groups show evidence of ancient Near Eastern ancestry and share certain mitochondrial DNA and Y chromosome lineages. The presence of shared lineages like HV4A2 among both Assyrians and Armenians suggests ancient population connections, but the precise nature of these relationships remains unclear. Perhaps most intriguingly, genetic studies have found that contemporary Assyrians and Yazidis from northern Iraq cluster together genetically, but separate from other northern Iraqi populations. Both groups may represent populations with stronger continuity to the original Mesopotamian genetic stock, suggesting that they preserved ancient genetic signatures that were diluted in other regional populations. This genetic clustering between Assyrians and Yazidis is particularly interesting because it occurs despite significant religious and cultural differences between the two groups. The global dispersion of Assyrian populations during the 20th and 21st centuries has created new opportunities for genetic research, while raising questions about genetic preservation in diaspora communities. Large Assyrian populations now exist in North America, Australia, Europe, and Russia, often maintaining strong cultural and religious traditions despite geographic separation from their ancestral homeland. The cultural identity of modern Assyrians is vividly expressed through their distinctive clothing styles, intricate traditions, and evolving practices, serving as both a reflection of millennia-old heritage and a living adaptation to contemporary realities. In everyday life as well as in ceremonial settings, Assyrian clothing acts as a powerful symbol of continuity, resilience, and pride. Traditionally, Assyrian women have favored vibrant dresses made from richly colored fabrics, often adorned with elaborate embroidery that incorporates motifs inspired by nature, ancient Mesopotamian iconography, and geometric designs. These dresses are typically accompanied by ornate belts, sequined sashes, and sometimes golden or silver jewelry, which are passed down through generations as treasured family heirlooms. The headscarf, often brightly patterned and meticulously folded or pinned, not only completes the attire but also marks status, marital stage, and communal respect. Men's clothing likewise is rooted in ancient tradition, balancing practicality with ceremonial elegance. The characteristic shirkana, a long tunic, is frequently seen at weddings and church events, typically sewn from high-quality fabrics in neutral or earth-toned hues. It is often teamed with embroidered vests, a broad, intricate belt, and occasionally a traditional head covering known as komta. In rural villages or special occasions, men may wear heavier cloaks or capes during colder months, reflecting regional adaptations that have survived for centuries. Assyrian cultural practices extend far beyond visible attire, encompassing rituals, music, language, and social organization. Religious observances remain central to Assyrian life, with church services offered in Neo-Aramaic dialects and liturgical ceremonies passed down through centuries. Festivals such as Kabi Nisan, the Assyrian New Year, Easter, and patron saint commemorations gather dispersed communities in vibrant displays of unity. Wedding ceremonies are elaborate affairs, often lasting several days, blending ecclesiastical traditions with secular celebration. Brides are typically adorned in dazzling dresses featuring metallic thread or beadwork, and grooms in finely tailored suits or traditional tunics, surrounded by guests who display a breathtaking array of Assyrian textile artistry. Historically, persecution, displacement, and migration have deeply shaped Assyrian self-conception. This ongoing dialogue between past and present ensures that Assyrian culture and community life will persist, changing yet rooted in remembrance and hope.